For problem 8b, again, we need to find the critical numbers and then the intervals of increase or decrease using the first derivative test. So first, to find the critical numbers, we need to take the derivative. So we have x to the minus 2 times ln x. I'll rewrite that real quick as a fraction. That's ln x over x squared. So x to the minus 2 is on the denominator. So I'll do this one by using the quotient rule. So our derivative of g of x is the derivative of the top times the bottom, which would be 1 over x times x squared, minus the derivative of the bottom times the top, which would be 2x ln x. And that's all over the bottom squared, which would give us x to the 4th power. So you can see here 1 over x times x squared, that actually cancels to just give us x. So we get x minus 2x ln of x. So I can factor out an x from the numerator because we have an x here and an x here. So this is 1 minus 2 ln x all over x to the 4th. Then you can see this x cancels with one of the x's on the bottom. And we would get 1 minus 2 ln x, which is all over x cubed. So this is our derivative of our original function. And we need to find the critical numbers. So remember, the critical numbers are what makes the derivative 0 or undefined, as long as those values are in the domain of the function. So what would make our derivative 0 is if the numerator was equal to 0. So if the numerator was equal to 0, we get 1 minus 2 ln x equals 0. In other words, that means ln x would need to equal 1/2. And then to solve that for x, we raise e to the power of both sides of this equation, and we would get x is equal to e to the 1/2. In other words, the square root of e. For our derivative to be undefined, we would need the denominator equal to 0, which would just be x equals 0. Problem is that we can't use that as a critical number because that's not in our domain. We can't plug in 0 to our original function, so therefore it couldn't be a critical number. We only have one critical number, and it's e to the 1/2. So now we're going to use our first derivative test with a number line to check our intervals of increasing and decreasing. So in this case, our number line is not a two-sided infinite number line, because the domain of this function is only things that are greater than 0 anyway. So we really have a number line that looks like this because our domain is only positive x in the first place. And our only critical number is e to the 1/2. So to figure out our intervals of increase and decrease, we just need to test a number on each side of e to the 1/2. So since we're only plugging in positive numbers, because that's what our domain was, this x cubed on the bottom is always going to be positive. So we don't need to check that. We're only checking the numerator, 1 minus 2 ln x, and we're seeing if that's positive or negative. So here's where you can kind of use a trick to make this a little simpler. Since the only value of x that we're plugging anything into is an ln of x, it makes sense to, instead of choosing numbers like 0, 1, 2, 3 whole numbers, we should pick powers of e, because then it's going to make it simpler. So in order to pick a number bigger than e to the 1/2, I'm just going to pick e. E is bigger than e to the 1/2, the square root of e. So that'll be my bigger number. And then something lower than e to the 1/2, I could put like e to the 1/4, for example. So when you're choosing your numbers, don't always just pick a whole number, because if your function, or if the only thing you're plugging x to is an ln anyway, then it would be easier for it to be an e and not just a whole number, so that you could figure out what it is. So when I plug in the lower number, e to the 1/4, ln of e to the 1/4 is 1/4. 2 times 1/4 is 1/2, and 1 minus 1/2 is positive. When I plug in e, ln of e is 1. So this becomes 1 minus 2, negative. Again, I didn't worry about the denominator because that's always positive for these anyway. So there's my number line with my positive and negative on there. So then my intervals I'm increasing from 0 to e to the 1/2. And I'm decreasing from e to the 1/2 to infinity. So those are my intervals of increase and decrease, and my critical number, my only critical number was x equals e to the 1/2.
The Teaching Center, UF's Learning Resource Center.